Okay, chapter 10 has kind of a big change from where we are. We're factoring, we're doing everything else we were doing back in chapter 7, chapter 8. And chapter 10 kind of gets back to more of your regular math, if you want to call it that. This is, your basic, to me, it's a little bit more straightforward math than a lot of the math we've been doing so far. So here's what we're looking at with chapter 10. First section, section 1, we have, there are 12 different objectives, but the good news is that most of this is stuff that you can do with your calculator in a lot of the different cases on these. The very first objective that you get, you almost look at the problem and you go, it's got to be a joke, right? It says find the square root of 16. Well, it's 4, right? Find the square root of 25. It's 5. There you go. Just that straightforward. Here you go. Here's an objective. They call this perfect square roots because when you take the square root of it, you get a nice, even round number. Okay, objective number 2, they kind of use the square root part to get you ready for objective number 2 and 3 because objective number 2 is what they call the intro to Pythagorean theorem. And then objective 3 is Pythagorean theorem, so we'll go ahead and kind of show both of you here anyway. But the Pythagorean theorem is this, is that if you have a right triangle, and you know it's a right triangle because they'll go back and mark your 90-degree angle here. The two sides that touch the right angle, that's always the side A and B, which they call the legs. The side that doesn't touch the right angle, that's side C, which is the hypotenuse. And basically this is the Pythagorean theorem says if you take the two short sides, square these two sides separately, so do A squared and B squared, add those two things together and that will equal the longest side, or the hypotenuse squared. Okay, in objectives 2 and 3, they're going to keep going back to this formula and just give you the different, because there's only 2 different cases they can give to you on a problem like this. That either one of the legs is missing or the hypotenuse is missing, and they're going to give you the 2 different cases on this one and just have you go back and work these things around. Now, the way it's going to work in objective 2, I think all the answers should come out to be all perfect whole numbers when you get finished. Objective 3, you'll get some whole numbers, you'll get some that's in decimal numbers. And again, you're still really coming back and using your calculator for a lot of different parts of this. Okay, so the first problem may look something like this. May give you 15, 20, and x, where 15 and 20 are the 2 legs, and then x is going to be the hypotenuse, and they'll tell you, all right, just find a missing leg. Okay, so A and B is your 15 and your 20, and there's really no rhyme or reason to which one is which. So it's 15 squared plus 20 squared equals x squared. And from there, it's just using your calculator. 15 squared is 225, 200 squared is 400. Add those two together to get 625. And once you've gotten the numbers down so that you have something equals x squared, or whatever the variable may be that they throw at you, here's where they're going to tie back to that first objective, that, okay, if you get it down to x squared, to simplify this thing, you're just going to take the square root on both sides. Okay, check the square root of 625, that comes out to be 25, and when you square x squared, that's just x. So then you got your missing link there. That would be 25. Okay, so they use the basics of, okay, if you take a square root to get the number in objective 1, you're going to do that. Now, and then they tell you in objective 2, okay, here's where you can use that information to kind of go back and do that same thing. That if you do Pythagorean theorem with this part, you get down to a number and it goes in here. Okay, works out great as long as that's a perfect square. If the number that they give to you is not a perfect square, and this basically would be objective 3, Same problem, same triangles, type stuff when you're going through on this one. But this time the numbers are not going to come out to be perfect. So we'll go with x, 10, and then 18. Okay. And again, whatever numbers are connected by the right angle, that's your a and your b. So that's x squared plus 10 squared. And that's going to equal 18 squared. Okay, so 10 squared is 100, 18 squared is 324. And with your two, basically depending on where they give to you, this is your only two options that you're going to have when you do the Pythagorean theorem. Either the two numbers are on the same side and the x squared is over here where you can add these two numbers together. The other option is that they're going to spread it out where you've got one number on one side, one on the other, and the x is over here. Well, from here, all you're going to do then is just subtract this number, move it over to the other side, so that you get x squared equals 224. All right, and then as soon as you get that, then again, you're going to take the square root of both sides. Okay, if you take the square root of 224, it's not a perfect square root, so this should be one that they should have you round this, and they should tell you to round this answer off probably like to 2 decimal places. If you check that, that should come out to be like 14.97. So on a problem like that, if it's not a perfect square root, they'll tell you to round it to 2 decimal places or 3 decimal places or whatever number it is that they're looking for. The problem that I was doing when I was working through these earlier, it rounded off to 2 decimal places. So I'm assuming that most all the answers would kind of be this way. Okay. And with Pythagorean theorem, again, that's really the only two choices. When they give you, either they're going to give you A and B, and the side C is missing, like you had back here, or they're going to give you side C and either A or B is missing, but it'll always be that same setup, that either, that's the only two choices you get when that one. Either one of the legs is missing, like this one was, or you can go back to the previous example where the hypotenuse was missing, and that's the only two ways that they can throw Pythagorean theorem at you. And it has to be one of those two options when it comes down to it. Okay, objective 4. Has you to find all square roots if possible. Okay, and a little bit different on this one. That instead of giving you a number inside the square roots, they'll say, all right, here's a number. Now go back in and take the square root of it. All right, now here, and again, here's the difference between the wording on the two, and really it's all about the wording. If we go back to example 1, let me just scroll back up real quick. That with example 1, it just said, find the perfect square root. You just took the square root of it. You had the number here. We're good to go. If it says find all the square roots, they're kind of giving you a little hint on this one. That if you work this thing out, there's one minor difference on this one. Alright, if you try to take the square root of a negative 144 with any calculator, it's going to give you an error message. Which means if it's an error message, means it's not possible. So for one like this, if you do the square root of any negative number, it should give you an error message. This is one where it would just be not possible. And that should be one of the options when you click on and start putting the answers in, that they'll have it where you can list your answer, and then they'll have an option that says not possible or undefined or something like that. Okay, for part B, they'll say, all right, here's a number that's 121. Find all the square roots of it. Okay. Square root of 121, that's a perfect number. That's just 11. But here's the catch on this one. When they say find all the square roots, if it's possible, it would be 11, but at the same time, it could be, remember we talked about when we were doing x squared, how you have two answers? This one's kind of the same thing, because you could do 11 times 11 and get 121. You could also do negative 11 times negative 11. So for this one, this is where you could put a plus or minus. So if they say find all the square roots, then they're assuming, all right, you can do positives and you can do negatives on this thing. A little bit weird when they ask you that part of it, but that's pretty much about what they're looking at. Yeah, so if it's a negative number, you try to take the square root. It's not possible. If it's a positive number, take the square root of it, and just realize if it says find all the square roots, you need a positive number, and you also need a negative number when you talk about it there. Okay, objective number 5. Still says find the square root. Square root of 50 over 32. Okay, because it is a fraction. So you have to look at the number on the inside like it's a fraction. So it's 50 over 32. Could you simplify that fraction? Both even, right? So you always divide it by 2. So before you do anything with it, if you have a fraction, because you may look at it and go, well, 50 and 32, those aren't perfect square roots. No, they're not. But in this case, they're both even. So go ahead and divide them both by 2. We'll make it 25 over 16. And hopefully you go, oh, okay, well, if that's the case, then if I'm just taking the square roots, if I can divide them both by 2, simplify the fraction, now I've got 25 over 16. Well, square root of 25 is 5, square root of 16 is 4. So I can just make that 5 over 4. Right, now again, the difference on that one is that it doesn't say find all these square roots. If it did, you'd put a plus or minus. If it just says find the square root, they're saying, all right, don't worry about the whole plus and minus thing. Just assume everything is positive. Take the square root of the number, and then tell me what you get there. Yeah, so if that was A, I'll just give you one more here real quick. B would basically be something like this. Let's say it's 45 over 20. All right, 45 and 20. Again, neither one of those are perfect square roots, so you've got something you can divide out of those two things. They both end in 5 and 0, so you can definitely divide a 5 out of each one of those. So if you do that, that would be the square root of 9 over 4. Again, if you do the square root of 9, that is 3. Square root of 4 is 2. So that would just be 3 over 2. Okay, objective 6. Still doing square roots on this one, but it says, all right, this time we're going to change it, so we're doing square roots with signs. Not signs like give peace a chance, make love, not war, save the ozone, different kind of signs on this one. No, not that kind of signs. This is more of just, they start throwing negatives all around you. When you're doing something like this. Negative square root of 25. And we'll just, 3 or 4 different examples to kind of see what's going on. Okay. And again, as long as the negative's on the outside, you just kind of ignore that part of it. square root of 25 is 5. The negative hangs out front, so that answer would just be negative 5. Okay. But if they give you a negative on the inside, doesn't matter what you have on the outside. If you've got a negative number on the inside, that's going to be not possible or not real or undefined or whatever option they give you that's not an answer on this thing. So anytime you get that negative number on the inside, doesn't matter what you have on the outside of it. It's just going to be not possible when you go through this thing. And that's really all they're going to do is they'll give you some different numbers and just have you, sometimes they put negatives inside, sometimes they put them outside, sometimes they got both. It could even be something just as simple as like negative square root of 1. Square root of 1 is 1. If you put the negative in front, then that makes it a negative 1. Okay, objective 7. Still doing square roots this time, but it's square roots. Raised to even exponents. And on all these, they should give you a couple different numbers to look at, kind of go through this part of it. So it's negative 9 squared for A, and then part B, we'll do like negative 2 to the 4th. Okay, now on these, it's not anything more than what it is. You're still they give you some number to do to a power, so if it's negative 9 squared, well, go ahead and tell me what that number is. Negative 9 times negative 9, 81. Then what's the square root of 81? Yeah, just 9. So all they're showing you is that, okay, if you have a negative number on this thing, just go ahead and work this thing out and see what you get. Negative 2 times negative 2 is 4, times negative 2 is negative 8, negative 8 times negative 2 is 16. Square root of 16 is 4. Okay, if you keep saying, where's the tricky part on this one? There's not a tricky part here. You basically just, whatever number they give to you, you do it to that power and break it down so it's just a number, and then take the square root of that number, and then you've got what you're looking for there. So there's really no trick questions on this part. It's kind of, objective 8, still the same thing. It's still not anything tricky on this one. The biggest thing they're going to do on number 8 here, this time, is that it's doing not just numbers. Basically, they're going to say, we're going to simplify radical expression. Okay, so whether we're doing objective 8 or objective 9 or objective 10 or 11 or 12, any of these are all objectives that keep popping up from here on out in section 1. They're all pretty much the same basic setup when it comes down to this one. We have the square root of some number to a power. Let's say w to the 36. Okay, as long as we're talking about variables here, it's a really easy shortcut thing to do. And we're talking about square root. This is always understood to be 2 if we're talking about square roots. So anytime we're doing square root, basically they'll always put the root power. If you want to say it's the root index, that number always goes here. It's not the power. It's the opposite of power. It's It's what you're dividing by. So it's basically like an index here. So whatever that inner stud root is, or it's called the index, if they don't give you a number here, the index is always understood to be a 2. Okay, so here's the shortcomings thing. If they give you something that's an expression like this, to simplify something like this, you just divide the inside power by the index, which again is just your root. Okay, and the good thing on this one is they don't have you, sometimes you can get kind of bogged down in some of the details on this about whether something's negative. And so this one, they say, all right, don't worry about this. Everything is just regular division like you think it would be. So for this thing, it's just going to be W, and you're going to do 36 divided by 2. 36 divided by 2 is 18, and that's all you got to do. So you take whatever the power is that's on the inside of the square root or the radical that we're looking at, and you divide it by whatever the index is that's on the outside. And again, there's some details that I think when this is one of those things, when you get into some parts of pre-cal, you can kind of dig into the details and get bogged down. But it really just comes down to, okay, here's some numbers, just divide this thing and tell me what the answer is going to be. I think most all the problems that they're going to give to you is they're going to be assuming that everything is probably square roots. So you could have the square root of y over 100. So you're going to basically do 100 divided by 2. So it'll be y to the 50th power. And if it's anything other than square roots, it could be a fourth root. They'll put the 4 out there to know that, in this case, you got to divide by 4. So it could be t to the, 36. In that case, it's just 36 divided by 4. It's t to the 9th. Okay, now, again, they may explain it a different way, but I always try to give you all the shortest, quickest, fastest, easiest way that makes mathematical sense. And for this one, it's always just going to be that. Take whatever the power is here, divide it by the index. If there's not an index, it's got to be 2. If it's something other than 2, they'll write down what that index is that's here, and you just divide those two numbers and go from there. Somebody may be saying, what if it doesn't go even? It will right now. Everything's going to work out nice and perfect. If it doesn't, we'll show you that one later, because that, again, kind of comes a little bit later. Okay, objective number 9, same thing. They're going to tell you to simplify the radical, work through this one. The only thing that's different between objective 8 and objective 9. And now they put a number in front. And for this one, you can separate the two pieces. You can look at this as being the square root of 25 and the square root of x to the 14th. So you can separate it up into two parts to make it go through this one. Square root of 25 is 5. Since this is the square root of x to the 14th, again, you've got the understood 2 that would be here. Take 14 divided by 2, be x to the 7th. So for that one, 5x to the 7th would be the answer that you're looking for. It could be 81, the square root of 81, and then t to the 98th power. Okay. And if they don't put a power there again, or index there again, it's always basically 2. Square root of 81 is 9. You take 98 and divide it by 2, that is 49. And that would be the answer that you're looking for. Okay. And again, they all should be perfect squares. When you go through these, there's not going to be anything where you get decimal answers or anything. It all should come out to be nice and perfect. We'll build up to that eventually, but right now everything is working out nice and even for you. Objective 10 is cube roots. And it sounds like what it is. Now it's going to be the cube root of 27. And this is one of those numbers that, again, technically what they're wanting you to try to do on this one is that they're saying, okay, if you kind of go back to this problem back here where we could take this power and divide it by these two things, what they want you to kind of think about in this case is if you took 27 and broke it down, started doing the factor tree on it, it'd be 3 times 9. 9 would be 3 times 3. But that would be, make 3 was a bad number to pick here. 27 is the same thing as 3 to the third. And if you divided these two numbers, let's write the base with this part. Here we go. We'll do the base in blue, that way we can see a little bit better. I'll go back and pick another number because this one came out terrible. If you rewrite this one, 3 is this part, divide your power and your exponent. Divide your power and your index. Those cancel out, right? It's just 3 to the first power. If you have 3 to the first power, then that's just 3. So kind of the same thing on these. These should all be just numbers that's just a perfect square cube. And except for square roots, these are all cube root numbers. So, if you go through your list of cube numbers, it's going to be, 2 to the third, which is 2 times 2 times 2, which is 8. 4 to the third, which is 4 times 4 times 4, would be 64. 5 to the third, 5 times 5 times 5 is 125. So these are all going to be numbers, let's get 3s all together. If you had 3 to the third, that would be 27. So all these numbers should be numbers, if you multiply it all together, that they all come out every time to be just these nice, perfect little numbers that you get here. 6 times 6, 36, it can be like 216. So all these will be numbers that you can just punch it straight in. And again, with any good calculator, you can always just check it real quick, punch in the cube root of it, get the answer that you're looking for. And you've got everything that's here. And again, they're kind of wanting you to think about it back here, but really you can just punch that in your calculator and get the answer you're looking for. Okay, the wording on this one's a little bit different. It's finding nth roots of perfect nth powers. With signs. Okay. Oh, no. I'm sorry. Let me back up here 1 second. One more problem back here for objective 10 that could have one little thing here. And again, this is one of those things, if you kind of check it with your calculator, you can get this part. Alright, let's say it was the third root of negative 125. Okay, if you look back over here, we've got that the 125 would be 5 to the third. Now, on cube roots, if you do the square root of a negative number, it told us it was no solution, because anytime you do a negative times a negative, it has to be a positive. But since it's third root, what happens if you multiply a negative times a negative times a negative? Negative, right? So in that case, this could actually be a negative answer. So if it's a cube root, if they give you a negative number to cube root, that means your answer is going to be negative. If they give you a positive number to cube root, that means your answer is going to be a positive. So with cube roots, you can get a negative answer because it's something to the third power. But if you do a negative times a negative, that's a positive. If you throw one more negative in there, that does make the answer negative. So if they give you negative numbers on these, that's okay because of being the third power, it makes everything kind of work out there. But again, check it. Use your calculators. Just check it because these should all be numbers that you can easily check with your calculators. Okay, and then the last two objectives are basically this. Back to number 11 here. You're finding nth roots of perfect nth powers with signs. Okay, so we have the 4 through to 16. Okay, and probably the most important word on this one is that it's all perfect. So if everything is perfect, that means when you do these numbers, you come out and you get just some integer for an answer. 2, -5, 6, 12, 3. There's no fractions, no decimals. So this one, they're telling you if it's a perfect root, there's no fractions, there's no decimals on this thing. Again, they want you to kind of think about how you could break this thing up. But honestly, if you've got a good enough calculator, you can do the 4 through to 16. So if they're doing the 4th root, they're saying, all right, basically, what number to the 4th power would equal 16? Be 2, right? So if 2 to the 4th is equal to 16, we're doing the 4th root of 2 to the 4th, which means if you can match these two numbers up, then they cancel each other out. Yeah, so that would just be 2. So as long as these are perfect roots, then basically you can take this number and rewrite it to this power with the same index, and that way they'll cancel each other out and get just that number. Okay, we'll do the 5th root of -32. That they're telling you that this thing is the same thing of something to the 5th power. Go back and check your numbers real quick. That's going to be -2 to the 5th power. And again, as long as these two match up, that you can get this index and this power to match up, they'll cancel each other out. So that answer would just be -2. And with the way these numbers are set up, your answers won't be very big, because once you start getting past, 2s and 3s, when you start doing them to the 3rd, 4th, and 5th power, they get really big in a hurry. So all these numbers that you're going to do, they're all going to be pretty small numbers when it comes down to it. Okay, and the only thing they do different on objective 12 here, is they're going to throw some variables at you. So objective 11, they would give you the 5th root of 243. Objective 12, well, they tell you it's the 5th root of 243, x to the 5th. Okay, and here's where you can kind of think about breaking up into two parts. Kind of helps you to see it that way. So with the 5th root of 243, again, you've got to think about, all right, what number would this be written as to the 5th power? And again, it can't be too big. If you start checking real quick, that's going to be the same thing as 3 to the 5th power. So those two things will cancel and just give you 3 for this number. If you do the 5th root of x to the 5th, same thing here. These two things cancel. Give you an x. So that answer would just be 3x. About the only thing they could do that would be the least little bit different. Maybe something like this, the 4th root of 256, x to the 20th. But again, you've got to go back and figure out, okay, with 256, that's the 4th root of something to the 4th power. I've got to do the 4th root of x to the 20. So if you go back and check this one real quick, again, the numbers can't be too big because they get really big in a hurry. If you go back and check, obviously it's not 1s. If you check 2s, that would only be 16. 3s was back here, it's not that one. This is going to be 4 to the 4th power. 4 times 4 would be 16. If you do 16 times 16, that should be 256. But again, now you've got these two powers that match up with the index, so that number is just a 4. And if you do 20 divided by 4, that's going to make that x to the 5th.